Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math, and this is another session of Tutor Me Senpai. Welcome back, everyone. I'm Courtney, and this is another session of Tutor Me Senpai. Today, we're going to be jumping into a 12th grade topic, finding derivatives using the power rule. Now, the power rule is only one of many rules used to find derivatives. And it's not going to be able to find every derivative, but we're going to talk about which ones you will be able to find by using the power rule. Let's jump straight in. So the function for today is 4x to the 100th power all over 25. And we're going to be using the power rule to find its derivative. Now, in order to use the power rule, we have to make sure it hits the qualifications. And the only qualification is having a function that looks somewhat like this. If you want to add a little constant up front, a coefficient, then we can have a function that looks like this. If our function has this type of characteristic, then we know that we have a candidate for the power rule. So what this tells us is if we were to take a function that looks like this and find the derivative, so if this is fx, find the f prime of x, power rule tells us to take our a, keep the coefficient, right? Multiply it by n, whatever n is up here, times by x, we're keeping the same base, and this n that you have here, we're going to subtract 1 from it. So you're going to be taking your n and pretty much bringing it down. It's going to be brought down and multiplied by whatever coefficient is already there. And then we're going to subtract 1 from the exponent that's left. Okay? So if we want to throw a random example at this, we can do 3x squared, right? If we want to find a derivative, our derivative tells us we're going to keep our a, our coefficient, multiply by whatever the exponent was, so 2 in this case, keep our x here, right? And we're going to take the exponent and subtract 1 from it, as you see here. So the derivative in this case, when you multiply these together, it gives us 6x, and what's 2 minus 1? You get 1, so that's 6x, right? We're bringing our exponent down, multiplying by whatever coefficient we already have there, and then we simply subtract 1 from the exponent that was there. And we're getting our new exponent, okay? So we're going to apply this rule to this question. So the first thing I like to do is try to get it to look like f of x equals ax to the n, where we have a coefficient and we have our exponent here, okay? Right now we have a little bit going on and it might not be super clear if it hits this exact form. So what I like to do is let's change things up a little bit. We know that 4x to the 100 is all over 25. That means we can break this up into fractions, right? In which we have f of x equaling 4 over 25, right? Multiplied by x to the 100 over 1. If we break that up into fractions, then we can simplify this to 4 over 25 times x to the 100th power, because anything divided by 1 is just itself, right? So now if we look at this, our coefficient is going to be this 4 over 25. Our n is going to be this 100, so the exponent here is going to be 100. And now this whole thing looks very similar to this. And remember, if this is our function, we found our f prime of x to be a times n times x to the n minus 1. a times n, remember we're bringing the n down, a times n, so we're multiplying the coefficient and whatever exponent we're bringing down, times x to the n minus 1. Whatever the n was, we're going to subtract 1 from it to get our new exponent. So let's do that here. If this is our coefficient and this is our n, f prime of x tells us to 425 multiply this by 100, right? Times x to the 100 minus 1. Okay? And then when we combine this, we get 400 over 25 times x to the 99th power. So we can leave it like this, but we can simplify this just a little bit more. How many times does 25 go into 400? That's going to be 16. X to the 99th power. All right? So by following our power rule, knowing we started with something of the form coefficient a times x to the nth power, we started with something like that, we can apply our power rule in which we bring down the n, multiply by whatever coefficient is currently there, then we're going to subtract 1 from our exponent to get our new exponent. So we go from here all the way to here. This is our final answer. And if we look back at our question, does this answer appear in one of the options that we have there? Yes, it appears as D. So for this question, our answer is D. Well, that concludes another session of Tutor Me Senpai. Today we went over finding derivatives using the power rule. Like I said before, there are many different rules to find derivatives, but the power rule is probably the one you're going to run into the most as you're dealing with polynomials. And when I say polynomials, I mean monomials, binomials, or anything more than that. All of them can be tackled using the power rule. If there are any questions about what you saw today, I want you to write them in the comments. Let me know, and I'd like to address them if I can. If you found this video helpful, why don't you leave a like? Subscribe so you can see more videos that come out every week. And hit that notification bell so you know when they drop exactly. If you found this video easy to follow along, great. If you found it a little bit difficult to follow along, even better. In either case, I want you to practice, practice, practice. If you can nail the power rule, that is going to make finding derivatives so much easier for you in the long run. The power rule is a very powerful rule that you can take advantage of. I hope this helps with your homework, and I'm looking forward to seeing you again soon. I'm Courtney, and this is another session of Tutor Me Senpai.